Hello. Today we are talking about probabilities. I am chiming in today from LA, visiting my family in Los Angeles. That's why I'm in a different background. I think this is my niece's room. She's 6. Okay, let's jump right in. So this lecture on probabilities is very similar to our previous lecture on z-scores and percentile ranks. It's based on the same principles. So there shouldn't be too much new material here. Uh, Hopefully it could be a short lecture, but let's see. I have some very interesting exercise problems for us in the end that might take a little bit more time. But so same outline, probabilities, why do we need it? What is it? When is it used? And how do you compute it? And as always, what the link for the YouTube video for this lecture is going to be on the slide. All right, so what is probability? It's my husband. He's trying to take a nap. Okay, so probability allows us to estimate the probability or likelihood of something occurring. For example, if we're flipping a coin, it has a heads or tails. If we're just flipping it randomly, there's a 50% chance of us getting heads and a 50% chance of us getting tails. So you say the probability of getting head is 50%, the probability of getting tails is 50%. So how does this apply to research? So in research, remember we're working with a sample and we compute a statistic about the sample, and then we hope to generalize that finding to the population because we can't do research on the whole population. That's too expensive. We don't always have access to everybody within the population. For example, 400 something million in the US. So what we do is we gather a subgroup of people in a sample and we do research and compute a statistic like a mean, a median, a mode, or other types of statistics, and we want to generalize that finding to the population as a whole. But sometimes our finding might not match what's in the population. And so how do we know if it matches or not? We could use principles of probability to let us know and let us determine whether our finding is accurate or valid for what's occurring in the population. So here's an example. We want to determine the IQ level of all high school students. Let's pretend we recruited a sample of high school students, 200 high school students from all over the US, and we tested IQ and we find that the mean IQ is 110 in our sample of 200. And we want to generalize this to population and say the US population of high school students have an IQ of 110. But can we do that? Do we know whether the mean IQ in our sample matches what's really going on in the population? Well, we can use the principles of probability to figure that out. All right, so what's the formal definition of probability? So probability, so for a situation in which there are several different outcomes, where several outcomes are possible, the probability for any specific outcome is defined as the fraction of all proportion of all the possible outcomes. For example, the coin flip example again, there's only 2 possible outcomes, right? And so every time we flip a coin, we have one outcome out of 2 possible outcomes. So that's 1 over 2 or 50%. If you look at a deck of cards, for example, a deck of cards has 52 cards and it has 4, and each type of card is either ace, so 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And so any of these types of cards, there's 4 of them. So if I want to know the probability of selecting a king when I'm just shuffling a card and picking out a random card, there's a 4 out of 52 chance of selecting a king from this 52 card deck. So when you're working with probability, you have 2 assumptions or 2 things that needs to be met when you're working with probability. One is simple random sample. So that means everybody in the population has the equal chance of being selected. So that means that when I'm selecting, a card from the deck of 52, I have an equal chance of selecting any one of those 52 cards in that 52 card deck. So this means that there's no bias in the selection process. The other requirement or the other assumption is random sampling. This means like every time, that means that the probability of being selected stays the same no matter how many times we are sampling. Meaning if I'm taking a card from the deck, and every time I take one card, I have to return that card. Because every time I take one card, there's a 1 out of 52 chance of it being a certain card. And then if I take out another card, now the deck is 51 cards because I held out the first card. And now you have if I take another card, now you have a 1 out of 51 chance. So you see that the chance is not the same. So what you have to do is you have to put back the original card. So every time you take out a new card, there's still 1 out of 52 chance of being selected. That's called random sampling. That just means every time you sample means you select something from the population, or from, in this case, the deck of cards. Every time you select one, you have to put it back so the proportion stays the same. So it's always a 52 total from the population you're selecting from in this example. Probabilities and proportions are the same thing. So you might have a question to ask about probability, and you might have a question to ask about proportions. Just know that they're both the same thing. They're worded differently, but it's the same principle. So the question might be asked, what's the probability of selecting a king out of a deck of cards? So there's 4 kings in the deck of cards. So you say that for any random card you select, there's a probability of it being a king is 4 out of 52. You could also make this a proportion question, ask what proportion of the card consists of kings. And so there are 4 cards that are kings out of 52. So the proportion of the deck that are king is 4 out of 52. So you see, it's basically the same thing, and it just depends on how the question is being asked. What about percentile ranks? We talked a lot about percentile ranks in the previous lecture. Remember, percentile ranks is basically where you are in comparison to everyone else in the sample. So if you have an IQ score of 115, you could ask percentile rank at, meaning what is your percentile rank compared to other people? How do you rank compared to other people? Similar principle to SAT scores, LSAT, MCAT, any of those standardized tests. Yours are ranked in comparison to other people. And so that's what percentile rank means. Well, percentile rank is the same principle as probability and proportion. They're all basically 3 sides of the same coin, of this 3-headed coin, I guess. Let's look at an example to clarify things. So imagine you are part of a group that had their IQ tested, and your IQ is 115, and 70% of individuals in the sample have IQ scores of 115 or lower. So how would you phrase this as far as percentile ranks, probability, or proportion? So if you're asking a percentile rank question, you might ask, what is your percentile rank for your IQ score 115? And so the answer to that is that your percentile rank is 70, you're in the 70th percentile. Because remember, in the question, it says that 70% of individuals in the sample have IQ score of 115 or lower. So you being 115, that puts you at the 70th percentile, meaning your IQ score is higher than 70% of the sample. So one way you could make this a probability question is asking, what is the probability of randomly selecting someone from the sample with an IQ score of 115 or lower from the sample? So the probability of selecting someone from the sample with the IQ score 115 or lower is 70%. So very, very similar to the percentile rank question. You could also ask what's the probability of selecting someone with IQ score of 115 or higher from the sample. So you know if 70% had a score of 115 or lower, then you know obviously the other 30% it's going to have an IQ score of 115 or higher. So just subtract 70% from 100% and you get 30%. So how would you use this example to ask a proportion question? A proportion question could be a question like this. What proportion of the sample has an IQ score of 115 or lower? And the answer is 70% again. So as you can see, there's a theme here, in that depending on how the question's asked, you just basically use the same math, and respond using the language of the question. So here's an interesting chart. You see here that this is actually a chart of IQ scores for adults. And it's different for what we have here in the sample. I just want to put this here for demonstration because our sample, IQ, no, I guess you could use this because never mind. This chart applies to our example. In the general adult population, the mean IQ score is at 100, and you see here that I think, oops, and you look here, where's the standard deviation? Yeah, the standard deviation is 10. So once you move, this is one standard deviation up is 110, and two standard deviation up is 120. So you see here, if you're within two standard deviations, you're in the average range. That's how you read this. You look here, from 80 all the way to 120. If you have an IQ score from 80 to 120, then you're in the average range. If you have the IQ score from 120 to 130, then you're in the high average. From 130 to 140, then you're high, and 140 and high is very high. If you go the opposite direction, if you go below the mean, if your score is from 70 to 80, then you're low average. From 60 to 70, then you're low, and from 50 to 60, then you're very low. Actually, this chart, this graph, you'll come across a lot, especially if you go further in your education with psychology, because some DSM diagnoses are based on these IQ charts. The diagnosis of intellectual disability, the way they determine if someone meets the diagnosis of intellectual disability is if they are 2 standard deviations below the mean. I think it's two or three. I don't remember. Yeah. So in any case, just know that IQ scores is used in diagnosing individuals, and also used for putting people in gifted programs as well. So some students may score very high on the IQ test, and then schools may put them in special programs for giftedness, and they put in special classes, get extra resources to help them. And so there's a lot that goes into is associated with your IQ score. Okay. So when is probability or proportions used? Like I mentioned earlier, probability is used to determine whether a sample statistics matches the population parameter. So it lets you know how accurate your research is, whether that it can be applied, whether it's able to be generalized to the population. So let's look at this example. This is a real research. This table is from a real research study conducted by SAMHSA in 2019. So SAMHSA stands for Substance Abuse and Mental Health something. It's a federal program that does substance use and mental health research. And so for this particular 2019 study, it showed that out of all the adults in the US, 9% of those who are Asian and 12% of those who are white, non-Hispanic white, experience serious psychological distress. So how do they know this? How do they know that 9% of Asians and 12% of non-Hispanic whites in the US experience psychological distress? Did they measure all the Asian and white, non-Hispanic white individuals in the US to get this? No, what they did is they took a random sample of people in each of these groups, and then they measured the psychological distress, and they use principles of statistics and probability to determine, yes, this is probably likely that the sample that they have matches what it is in the population. So the study of probability really helps us identify whether we could generalize our sample findings to the general population. And what's said here is the same as said in the table here. 9% of Asians experience psychological distress. Excuse me. And 12.7% of non-Hispanic whites experience psychological distress. And the ratio is basically just this number divided by 12.7. So meaning that about a little more than half, like Asians experience about half the rate of psychological stress? Let's see. And divided by 12.7, it's 0.70. Yeah, I'm not sure what this number means actually. I'll get back to you on that if I remember. Okay, so how do you compute probability? It's straightforward. Okay. Well, this definition, this form, I guess the formula sounds really kind of confusing, but it's not really. And this formula you would normally use only if you're looking for a single probability value, like if you have a, a word problem and asking you for probability. Basically, if you're trying to find the probability of A, the formula is the number of outcomes classified as A over the total number of possible outcomes. So you just use it as an example to demonstrate. What's the probability? Here's the example question. What is the probability of getting heads on a coin flip? So the probability of getting heads is the number of outcomes classified as heads. So that's 1 out of the total number of possible outcomes. So that's 2. There's only two outcomes, right? Heads and tails. So the probability of getting heads is 1 out of 2, or about 50%. Another example question. What's the probability of getting a queen when randomly selecting from a card deck? So we know that it says queen here, but then it says king on the bottom. So I need to change this. Okay, so we know that there are 4 queens in any 52 card deck. And so the probability of queen is 4, because there's 4 of them, out of 52, because there's 52 total cards. And so about 8%. You divide 4 by 52, which is 0.08. You multiply that by 100, then you get 8%. All right, so how do you compute a probability or proportion when you're working with a data set, which is what we'll be doing more of in this class, and probably what you'll be doing more of in practice as well. So first, you have to convert the X value to Z-scores, then convert the Z-scores to percentile ranks. So same thing that we did last time when we were trying to estimate percentile ranks. It's basically the same process. So here's a formula in your Google sheet. Create a new column, enter this formula, XX minus M over SD, replacing the XX value with a single X value that's in the variable, the data set. Then replace M with the mean of the sample and SD with the standard deviation sample. Then after you get the Z value, you convert the Z score to the percentile rank, and you do that by entering this formula, equals norm S dist, Z, replace Z with the Z score. And then there are 3 possible questions that you will get about the percentiles or probability of proportions. And so pay attention to that. This part is most important, because how you answer the question is based on how the question is asked. If the question is asking about percentile rank of an X value, then you just look up the percentile rank and use that number. And remember, we estimate the percentile rank in this step here. If the question is asking about the probability or proportion of an X value or lower, then same thing as the previous. You just look up percentile rank and use that number. If the question is asking about the probability or proportion of an X value or higher, then what you do now is you look at the percentile rank and subtract it by 100. So just remember these three categories. So now let's do some exercise problems. We're working with example data set here. So in this data set, imagine you have the IQ scores for 270 students in a Palo Alto high school. And so these are the questions, and there's going to be questions about percentile rank, probability, proportions, and some clinical questions as well. All right. So as always, it's easy just to copy all this and then put it into the data set, so we don't have to go back and forth. So here's the data set. You see here, there's a lot of students. It's 270, and they all have IQ scores here for everybody in the high school. All right, so let's copy and paste the questions here. Paste special, values only. Now you can just put questions here. Both this. Move all this column wider to try to accommodate everything. Okay. So hint, I nicely included a hint for us. First, convert X variables to Z scores and percentile ranks, then sort the data by the X values from smallest to largest. Okay, so how do we convert X variables to Z score and percentile ranks? Look back in the lecture. It's always in the how do you compute it slide. See, computing proportions for working with data sets. Convert X values to z-scores, then from z-scores to percentile ranks. Let's copy this. Copy, go back to our file here, and make another section for instructions. Special values only, so it doesn't mess with the format. This is easier to read, and bold this. Right. So first, convert X values to z-scores, then from z-scores to percentile ranks. Yes, that's what we're doing. Okay, here's the first step. Convert from X values to z-scores. In the Google Sheet, create a new column, enter the following formula, equals XX minus M all over SD. M is mean, SD is standard deviation. So replace XX with a single X value, replace M with the sample mean, and replace SD with the sample standard deviation. Okay. So we need the mean and standard deviation for the X value. So remember how we do that is by computing it. So mean and standard deviation. Okay, so mean is, formula is equals average, AVERAGE, parenthesis. Click on the whole column. This selects everything, even the heading, which is okay. And then close parentheses and enter. And that's the mean. Standard deviation, remember the formula is equals STDEV, parenthesis, and click on the whole column and close parenthesis and enter the standard deviation. And I want everything left aligned, so I'll just highlight everything and adjust the alignment. Okay. Remember, we're working with usually working with just 2 decimal points, so we'll reduce it to decimal points here. Reduce decimal points. Easier to read. So this. Okay. So now we could convert from X value to z-score. So now create a new column. This is the IQ score, z-score. And we just enter this formula here, equals parentheses XX minus M all over SD. Remember, XX is the X value here. M is the mean for the sample, which is 99.86. SD is the standard deviation, which is 15.45. Enter. And remember, Google allows us, gives the option to apply the same formula for everything in the column. So if you want that, so hit the check mark. Go to heading. Remember, we only want 2 decimal points, so highlight everything and click on this to reduce 2 decimal points. So this is the z-score for the IQ variable for each one of these X IQ scores. All right, so what's the next step? I'm just gonna put here to indicate we complete these steps. Right. Now we convert z-scores to percentile ranks. So in Google Sheet, create another new column, enter the following formula, and replace ZZZ with the z-score value. Okay, so let's do that. So this is the IQ score that is the percentile rank. And what we do is enter this formula. Z equals norm equals norm S this and Z. Remember, you place the Z with the Z values, which is right next to it. You hit enter. And Google will apply this formula for the rest of the column. You want that? Let's go this. And remember, we don't need this many decimal points. Let's bring it down to just 2. And since we're working with percentile here, we can just click on the percentile button and it converts the percentile into percentages for us. And we will even need 2 decimal points because percentages uses each whole number. Right, so now we did this step. First convert X variables to Z scores and percentile ranks. And now we need to sort the data by the X values from smallest to largest. Okay, remember the way to sort it is by highlighting all the columns. You go to data, you go to sort range, and you go to click on data has a header row and click on the row that you want sorted by, which is the X value. And then you go to sort. Okay, so what I did is sort the X values from smallest to largest here. All right, so now we can answer these questions. Let me pull this over, delete this, just so we can get everything to fit on one screen. Delete this. Oh, here's the question. What is the percentile rank for someone with an IQ score of 71? So here we're looking for percentile rank. Right. So percentile rank for someone IQ score 71. Remember, there are 3 different types of questions about percentile, probability, proportion. And we look down here, we're working percentile rank. We just look up the percentile rank and use that number. So the question is, what's the percentile rank of IQ 71? So let's look at the IQ value here. And here's 71. And we look at the percentile rank column. So it's 3%. So someone with a IQ of 71 has a percentile rank of 3%. That means that they have an IQ that's higher than just 3% of the everyone in the sample. And this person is student ID number 41. So percentile rank of IQ of 71 is 3%. Next question. What is the IQ score for someone with a percentile rank of 38%? IQ score. All right, so we were working with a percentile rank. Again, look down here. Percentile rank, when you look working with percentile rank, you just look up the percentile rank and use that number. All right. But this time we're working backwards. We have percentile rank, we had to find the X value. So let's look up percentile rank of 38%. So we look at this column here, percentile rank column, 38%. Here it is. And then what is their IQ score? It's 95. So you see here, everyone who has, undo. So you see here, everyone who has a percentile rank of 38% have a score of 90, IQ score of 95. So go back. So IQ score 95. So someone who has an IQ, what is the IQ score for someone with a percentile rank of 38%? That is not IQ score 95. So now we have a probability question. What is the probability of randomly selecting someone with IQ of 96 or lower? Okay, so this is a probability question. We look down here. So we're looking, if the question is asked about the probability of or proportion of an X value or lower, it falls into this category. All you have to do is look up the percentile rank and use that number. Okay, so we're looking for 96 or lower, IQ 96 or lower. So look at 96. It is. And we just use percentile rank, which is 40% probability. So again, the question is, what's the probability of randomly selecting someone with IQ 96 or lower? There's a 40% probability of selecting someone with the IQ score of 96 or lower in the sample. That's how you would answer that. What is the probability of randomly selecting with someone with IQ score of 96 or higher? So this time we're not looking at 96 or lower, we're looking at 96 or higher. So again, look down to types of question, and it's asking, usually when proportional probability, they're asking about either lower or higher. And so the way you answer it is different depending whether they're asking lower or high. If it's lower, then you just look at the percentile rank and use that number. But if it's higher, then you look at the percentile rank and subtract that number by 100. So 96 So you're looking at IQ score of 96. Again, the probability is 40%. And then you have to subtract it by 100. The probability equals 100% minus 40% equals 60%. So the probability of selecting someone with an IQ score of 96 or higher is 60%, which makes sense, right? Because the other question was, what's the probability of selecting someone with an IQ score of 96 or lower? That was 40%. So if so if you're looking for someone with IQ score of higher, it has to be the other 60%, right? We add 40 to 60 is 100%. Okay, what is the probability of selecting someone with IQ score 120 or higher? So again, or higher, we're supposed to look up the percentile rank and subtract it from 100. So look up IQ score 120. It's IQ score 120. And it's 90%. So probability equals 100% minus 90%. So there is a 10% probability of selecting someone with an IQ score of 120 or higher. This makes sense. So that's a very high IQ score. So you have a very low. Not that many people in the sample have that IQ score. So the probability of selecting someone with that higher IQ score should be pretty low. All right, we have a proportion question. What proportion of the students have an IQ score of 71 or lower? So again, this question is about probability or proportion. And if it's a question about lower, then you just look at the percentile rank and use that number. So you look up percentile rank I look up the IQ 71. 71 right here, the percentile rank is 3%. What proportion of students have an IQ? So, excuse me. So the way you would read this is the question: and what proportion of students have an IQ score of 71 or lower? The answer is 3% of the students have a 3%. 3% of the students have an IQ score of 71 or lower. What proportion of the students have an IQ score of 71 or higher? Remember, if it's higher, then you subtract it by 100 from 100. So this is another proportion question. You look up 71, again, it's 3%. So what you do is 100% minus 3%, get 97%. So the question is, what proportion of students have an IQ score of 71 or higher? The answer is 97% of students have an IQ score of 71 or higher. So most people, 71 is a pretty low score. So only a few students have that score. So, and 97% of people have scores higher than that. Okay, here's some clinical questions. This is interesting for those of you who want to go on to graduate school in psychology, and maybe you want to work in a school or do testing for ADHD or giftedness, because they use IQ a lot for those types of programs. According to DSM-5, one criteria for the diagnosis of intellectual disability is someone with IQ score of less than 2 standard deviations below the mean, or IQ score of lower than 70. Which participants in the sample meets that criteria? Let's see figure. Let's go back to the figure. Here's the figure. So you see here, yes, this is his IQ score 70 or lower. So anyone who's below this value is considered to fall into the category of intellectual disability. So you see here by the descriptors here, that would be someone with either very low IQ or extremely low IQ. So between 40 and 60 is extremely low, and 60 and 70 is very low. And if you fall in either of those categories, then you might meet the criteria for intellectual disability. Back to the question. So which participant in the sample has the score of 70 or lower? So you see here, we already organized this by smallest to largest. So we look at where 70 is, and here's 71. So these scores right here, right? here are less than 70. So these students right here would meet potentially meet the diagnosis of intellectual disability. So I just highlight these, copy it. It's asking about which students, so just enter the student ID number right here. Student. Please. And what I'm going to do is delete and put a comma in between these values. There you go. The question is, which student has IQ score 70 or below and would meet the diagnosis for intellectual disability? Students number 89, 260, 195, 35, 160, 224, 198, 241, and 254 would meet this, would be in this criteria, or be in this group. Next question. Children and teens can be placed in gifted programs if they have an IQ of 130 or higher. Which participants in the sample meets the criteria for giftedness? Let's go back to our chart here. So 130, you see here, 130 or higher would mean that the student has IQ that's either high or very high. So that means they're way above the average as far as the IQ. And usually when students fall into that category, they meet they could be placed in gifted programs. So they have certain classrooms or resources to help them. And so that's extremely important for some parents and students to be in that program. So, all right. So as a psychologist, sometimes you could do these testings to help get students into these gifted programs by giving them IQ tests. Okay, so if they have an IQ 130 or higher, which participants in the sample meets this criteria for giftedness? So again, look at the IQ score. It's from smallest to largest. So we go all the way down and look for 130, 130 or higher. So here it is. So these 6 students would meet the criteria for giftedness. And this is the student ID number. It is. Copy. And go back. Over again. Paste. Same thing, delete, comma, delete, comma, delete, comma, delete, comma, delete, comma. Okay, again, the question is, children and teens can be placed in gifted programs if they have an IQ of 130 or higher. Which participants in the sample meet the criteria for giftedness? So these participants meet that criteria. Participant number 66, 201, 65, 29, 265, 232. All right, and this answers all the questions for this exercise. You'll see down here that the answer sheet has that area already computed the answer, and it should match what we just did here. Yeah, seems like a match. 3%, 35, 40%, 60%, 10%, 3%, 97%, 3%, 95, 40%, 60%, 10%, 3%, 97%. Great. What about this question? Where is the IQ score for someone with a percentile rank of 38%? Yeah, I think I did this one wrong. Someone with a percentile rank of 38%, their IQ score should be 95. Okay, so it's right here, but I need to change in the answer sheet. It's 95. Take that. All right, that's it for this lecture. It's supposed to be short, but it turned out to be longer than I thought. Okay, see you all soon.